Jake, you ready for this?
Yes.
Jake, can you read this?
Oh, how cute is an imaginary friend?
So we're going to be talking about what, Jake?
Imaginary numbers?
Very good, Jake. All right, so we're going to be talking about imaginary numbers. This is all about chapter 7. Imaginary numbers. It's I like it. It's fun stuff. Okay. So here's where it comes from. In this world, everything is real. Okay? Everything's real. Like if we want to like measure out like the square root of 16, that's like 4. I can measure out 4. If I want to measure out the square root of 2, okay, that's easy. I can do that. I can make it. You're like, well, how? Okay, I can make a triangle that has a side of 1 and a side of 1, and the distance between those two ends is root 2. I can actually make that. But imaginary numbers, that's something we don't come in contact with in this real world. Okay, it doesn't happen in space. Okay, it's just like something we can't physically like touch. Does that make sense to you guys? All right. So imaginary numbers and complex numbers, okay, they come from square root of like negative numbers. All right. So basically what happens in math is like everything has to be kind of like balanced out. So we can like add and subtract numbers and the answer is like, there. Kind of think of like whole numbers, right? If we have whole numbers, which are like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? You can only add on that group of numbers. Why? Well, because what if I did like 3 minus 5? That's -2. That's not in that set of numbers. So what ends up happening is mathematicians were like, okay, whole numbers, we can only add. But what if I were to subtract? Is that answer in that group of numbers? And the answer was no. So then we had to like expand the numbers. So then we had like negative numbers. And then I was like, okay, well, now we can like add, subtract, and like multiply. But what if I divide? Well, if you divide like 3 and 4, you don't get a number in that set of numbers. So we had to bring in fractions. Do you see where I'm going with this? Well, we've been talking about square roots, right? And with square roots, yeah, you can take the square root of like all the positive numbers. But what happens if I take the square root of a negative number? And if you put that on your calculator, it says error. Everybody get out their calculator. Type it in. All right. Let's do the square root of -16. See what happens. It says like error, and then it gives you like a message. And it says like non-real. Right? So it says error non-real because it's imaginary. All right. Now, it doesn't mean we can't find it. It just means your calculator is not going to do it for you. So this is all about imaginary numbers. Now, it's very simple, okay? Very simple. The one thing I want to write at the top up here is this. The square root of -1 equals I. Okay. And I just stands for imaginary. Okay, so write that down. The square root of -1 equals I. Okay. Now, let's talk about this, Cody. We have the square root of 36. Okay. Now, a lot of these things, all right, I've been kind of just, I guess, spoon feeding you stuff, all right? And now it says the square root of -1 equals I. Now, Cody, I got to kind of take off the gloves, so to say, all right, and kind of treat you like an adult. You ready? Yeah. Okay. Most of these things up here, okay, they have 2 answers, right? That symbol is going to be denoted by a plus or minus. Whenever there isn't a symbol, we assume I want the positive answer. If I want the negative answer, I put a negative outside. If I want both, I'm going to put a plus and a minus. Now, why? Well, Cody, what times what gives me 36? Because that's what a square root means, right? So what times what gives me 36? 6. But we also have -6, right? So up here for the square root of 36, my answer, the one I want, is 6. Why? Because it doesn't have the plus or minus outside and it doesn't have the negative. Do you see that, Cody? Now, what's the square root of 36 for B? So it's going to be -6. Now we're going to come back to C, okay, because that's, new stuff. All right, let's talk about E. What's the cube root of 8? So we're thinking what times what gives me 8? 2, right? And now notice there is no like plus or minus outside. Why? Because it can't be -2, right? -2 times -2 is 4 times -2 is -8. So my only answer for D is 2. Are you guys okay with that? Now, what about this cube root of -8? -2. Because -2 times -2 is 4 times -2 is -8. You guys okay with that? Now let's go back to C. Now, why did I jump over C? Because this is the square root of -4. Now, if I asked you, Cody, what's the square root of 4? You would say, what? 2. So this up here, the square root of -4 is the square root of -1 times the square root of 4. Right? I can break it apart. And the square root of 4 is 2, and the square root of -1 is this thing called I. So it's 2 times I, and I just write it as 2I. Okay? So it's pretty straightforward. You just need to know that the square root of a negative number is going to have I in it. Okay? Lance, are you okay with all that? Yeah. Okay? And just like the 36 is up front, if I want the positive version of it, I'm not going to put the sign out front. If I want the negative version, I'm going to put the negative out front. You guys okay with that? This?
Yeah.
What's the square root of 4? 2. And then I just write it with the I in the back. What? Right there. That's what it stands for.
So it stands for -1.
I stands for the square root of -1. Okay? So that's a little bit of the notes there. Okay, inverse properties of nth powers and nth roots. The way I look at this, it's going to seem kind of silly. Okay. Basically, I'm going to break it down for you. All right, what I do is I'm going to use my hand. I typically use my right hand, doesn't matter. But I put my thumb on the number that's like in the square root. It's going to seem weird here. And I put my finger on the power of A, and I'll rotate my hand up like this. Okay, let me show you what I mean by that. All right, let's look at A here. Now, Leah, because you were kind of looking at me like, what the heck are you talking about? I put my thumb on that 3. Do you see that 3 right there? And do you see the 3 with the 4? And I rotate it up. And that's going to be my exponent to 4. Do you see that? 3, 3, rotate it up, and that becomes 4 to the 3 over 3. Do you see kind of how I did that? I just rotated it up. What's 3 divided by 3 there, Leah? So the cube root of 4 cubed is just 4, because 3 divided by 3 is 1. Do you see that? Now with B, I have the 3 out there and the 3 here, and I rotate it up, and that's going to become -2 to the 3 over 3. Look at that. 3 divided by 3 is 1, so this just becomes -2. Are you guys with me so far? Somewhat? All right, now Chris, C is a little funky because there is no number there, right? All right, but remember, it's the square root. The square root of 7 is like talking about a 2, right? So the square root of 7 squared is just 7. Okay? So the point of this is they kind of undo each other. Exponents and roots undo each other, right? The cube root of 4 cubed, it undoes each other. The cube root of -2 cubed, well, that undoes each other. The square root of 2 or 7 squared undoes each other. Julia, are you okay with that? So what would this one be for D? -3. And E, who do I want to pick on here? Jake,
But that,
be careful. It's my warning.
wait a minute,
First off, obviously these two are different, right?
yeah,
Because they're two different problems.
yeah. Well, it wouldn't be -3.
No, it would not be. Why would it not be? What's the difference between D and E, Jake? Parentheses. Remember, I've always said parentheses make a difference, right? Jake, what comes first in order of operations?
Exponents,
What's 3 squared?
9,
So what's the square root of -9?
it would be here, -3,
Well, remember, what's the square root of 9?
3,
What's the square root of -1, Jake? Did you write it down? I. So this is just 3i. I know I'm throwing a lot at you guys. All right. So a couple main things. First thing, square root of a negative number is going to contain I. I represents the square root of -1. Okay. So the way I like to look at it is this. I like to kind of forget about the negative sign. I like to deal with the number first. Like here, -3 squared, I'm viewing as the square root of -9. And I think to myself, Kaylin, I'm like, what's the square root of 9? 3. Right? And then I write 3i because it's a -9. Now, the stuff with the exponents, that's going to help you out, being able to rotate between roots and rational exponents. Why? Well, because you're going to want to be able to divide stuff. It's going to allow you to simplify things better. So being able to take the cube root of 4 cubed and rotate that up to make it a rational exponent is going to allow me to simplify stuff way quicker. Do you see that, Nikki Grantland? Took my thumb here, my finger, my pointer finger, and I rotated it up. So the number outside of the root, that's my denominator. The number inside, that's my my numerator. All right, so let's go on to the next page. Yep. So the next page talks about a little bit more of that. Okay, so you go through the explanation here. I'm not really going to do that. I'm going to walk you through it with some of these problems. All right, now it says evaluate. And that says 8 to the 4/3. Now, this is why it's so important. Okay, 8 to the 4/3. Let's think about this. 4/3. I can reduce that, right? How many times does 3 go into 4? 1. So this is the same as saying 8 to the 1st times 8 to the 1/3. Does everybody see how I got that? All right. Let me put in another step. 4/3 can be written as 3/3 and 1/3. Carolina, does that make more sense? Okay, we add the exponents. So 3/3 plus 1/3 is 4/3. Now 3/3, Carolina, is 1. Right? 8 to the 1st. Well, that's just 8. Now, 8 to the 1/3. Well, what does that mean? Well, it's an irrational exponent. So if I put my thumb on the denominator, my pointer finger on the 1, and I rotate that down, that's really talking about the cube root of 8 to the 1st. Do you see that? Cody, what was the cube root of 8? What? You answered it at the beginning of class. 2. So this is really saying what's 8 times 2? That's 16. Now, why might I want to do it this way instead of plugging in my calculator? I can, but eventually your calculator runs out of memory. You can't process it. Okay, like 8 to the 5th. Nikki Grantland, can you tell me what 8 to the 5th is? Yeah, hold on. Oh, that's a big number. Yeah, real big number, right? Do you see how quickly you kind of run out of room? So your calculator can only process so many digits before it runs out of space, okay? That's why they keep putting out like new processors for computers, because you can only process so many digits so quickly. So your calculator is like, to be honest with you, it's probably a little bit more powerful than it's like an N64. Okay, it's 64-bit. All right, just think of what they have now. Yeah, they're pretty sweet. So what we can do is we can break it down into its components. All right, 3 goes into 4 one time with 1 left over. So it's 8 to the 1/3. Your calculator can process 8 to the 1/3. Okay, and that was just 2. 4 squared times 3 or to the 3/2. Well, here's how I go about that. Okay, what do I do with those exponents? Jake, do you remember?
Well, get the right?
Multiply. So 2 times 3/2. What is that? Two times 3/2. 2's cancel, right? Which is 4 to the 3rd. You guys see where I got that? All right. 4 to the 3rd is 256. Oh yeah, it is 64. Sorry, thinking 4 to the 4th.
No, I'm a Nintendo fan.
What?
I'm a Nintendo fan.
You are?
Yeah.
Conversation was like 5 minutes ago, Jake.
Yeah, but you said 64 and then.
And 64.
Yeah, but now you put 64.
You big Star Fox fan?
Kind of.
Yeah.
Except the only.
Ocarina of Time?
And I don't have that N64 yet.
I do.
I like Majora's Mask.
Yeah, it was pretty good. Pretty good. So, all right, let's look at C. 25 to the negative 3/2. Well, why is this principle, like, why am I teaching it to you? Why does it make sense? Or why do we even need to know? Well, let's think about this. Kailana, 25, right? Can you think of 25 in a different form? 5 squared, right? So I could view this as like, all right, kind of what we were doing with that 8 over here, right? Or I could think of this as 5 squared to the negative 3/2. And then, right, you can kind of see I'm going to multiply those exponents. The 2's cancel, I'm left with 5 to the negative 3rd. What do we do with the negative exponent? Do you guys remember?
Oh, reciprocal.
Reciprocal. So then it's in the denominator. So this is 1 over 5 cubed, which is 5 cubed, anybody? 125. So being able to go back and forth between these forms, it is helpful. Okay, it allows me to compute large numbers fairly easy, or kind of like seemingly, I guess, scary things pretty quickly. All right, let's look at D. All right, without a calculator, D, what would I do? Not much I could do, right? Like I can't do 64 squared. All right, but think about it. Is there another way you could view 64? 4 to the third. And that's a real good one too, right? What about 125? How else could I view 125? So 64 over 125 is 4/5 to the third. Do you guys see how we got that? What times what gives me 64? Well, you could think like 8 times 8, right? You could write it that way. Or you can kind of see that 64 is 4 times 4 times 4, and 125 is 5 times 5 times 5. Okay? So 64 over 125 can be written as 4/5 to the third. And that whole thing is to the 2/3. What am I going to do with the exponents? Multiply them. What's 3 times 2/3? 2. What's 4/5 squared? All right. What's 4/5 squared? 16 over 25. Lance, is that what you were going to say? What? But isn't that like I'm not saying you're wrong, but how could you check to see if you're the same? You could do math, hit math, enter, enter. Same thing. All right. -16 to the 1/2, right? Well, first off, is this saying -16 to the 1/2, or is it kind of saying the opposite of whatever 16 to the 1/2 is? There's a difference, right? Is that negative linked with the 16, or is it not? And the answer is not, because look at E and F. There's a difference, right? F says -16 to the 1/2. Okay. And the other one says the opposite of 16 to the 1/2. So first off, what is 16 to the 1/2, Lance? No, don't use calculator. Think about it. How can I rewrite that exponent into a radical? Okay, I can do 4 squared. Or better yet, right? We could kind of take my fingers, put my one finger, my pointer finger on the 1, my thumb on the 2, and rotate it, right? And this is saying the opposite of the square root of 16. Do you see how I got that? 1, 2, rotated down. 2 is my thumb. It's outside the square root, right? And the 1 is the exponent of the 16. What's the square root of 16? So this is just -4. Yes, Steve.
But it felt like you rotated it a different way than you rotated it.
I rotated this one.
Always.
It's the way I do it. I can't really rotate my hand this way.
Oh, wait.
Doesn't really
Your
work.
other hand.
It's my right hand, same hand as you.
No, like.
Can you rotate your left hand like that? I use my right hand. Thumb goes on the denominator, pointer finger goes on the numerator, and I just rotate my wrist. Yeah, you can't do that, can you? Because you have to rotate it this way. It doesn't work. Only works for the right hand. Right hand rule. All right, F. Difference between E and F is this. E said the opposite of the square root of 16. This is saying, well, what is the square root of -16? Which is what, Julie? For I. If it has a square root of a negative number, it's going to be I. All right. What's up? This one? Here? What? F? Why is it for I? Oh, the 1/2. So the 1/2, I wrote it as a root. All right, so I'm interchanging. When it suits me, I use rational exponent like did. Right, that made my life easier. I used it. Do I really want to do the cube root of 64 over 125 squared? No, I don't have a calculator. I don't know what 64 squared is. Okay. I don't know what 125 squared is, nor do I know what the cube root is. But I don't need that because I can view 64 as 4 and 5, or well, 125 is 5 cubed. So I can rewrite it in a rational exponent form. Jake, I got you all fine. So I'm rotating. When it suits me, I switch to the form that's better for the problem. All right. Remember, as we go along in math, there's not one way to think about the problem anymore. I'm not going to do it just one way. I'm going to be like, hey, this way works better. We're going to do that one. Okay. Remember, it's like magic eye at certain points. You have to see that 64 over 125 is 4 over 5 cubed, which Hansi saw right away. All right. The more we do this, the better we get. Jake.
Wait, how did you get that through on D? How did you get the 3?
64 is 4 cubed.
Yeah.
5 cubed is 125.
Yeah.
So 64 over 125 is the same thing as saying 4/5 cubed.
It's the same thing?
Same thing.
Oh.
So we wrote 64 over 125 is 4/5 cubed.
Yeah.
Well, all of that's to 2/3.
Yeah.
So then we multiply these. 3 times 2/3 is just 2.
Yeah.
So that gave me 4/5 squared.
Oh, okay.
Well, I can square 4, there's no problem. It's 16. I can square 5.
Just confused how you got the cube.
All right. Now, being able to convert back and forth between these makes problems like this yeah, makes them pretty simple. There you go. All right. Now, it's asking us to rewrite each expression using rational exponents. All right. So let's not focus on this x. Let's just forget that. Let's look at this this root part. Thumb goes on the 4, pointer finger goes on the 3. I'm going to rotate that up. So I'm going to write this piece, just this piece, as x to the 3/4. Everybody see how I got that? Mike, sorta? Times x. So what's the exponent of the x, Jake? What's this guy's exponent?
4?
No, this guy, just the x.
1?
1. What's 1 plus 3/4, Jake, as a fraction?
1 plus 3/4. 1 3/4.
Or 7/4. Lance, do you know how to write the numerator with a rational exponent? It says the cube root of x squared. Okay, so I'm gonna put my thumb on the 3 and my pointer finger on the 2. I'm gonna rotate it up. So it becomes x to the 2/3. Do you see that? The denominator. Thumb, finger, that's 3/2. What do I do with these exponents when you divide? Do we add or subtract? Subtract. So 2/3 minus 3/2, common denominator 6. So that would be x to the 4/6 over x to the 9/6. If I subtract those exponents, I get x to the negative 5/6. Don't worry, we are going to go over this more. Main takeaways. Being able to rotate between the types of exponents and the square root of a negative number has I.